Reinforced concrete and prestressed concrete are two different types of concrete structural design that varies in how they achieve strength and how they carry external loads. In order to understand prestressed concrete, you'll have to clearly understand the basic concepts of RCC. RCC is a concrete reinforced with steel rebars in order to take tensile strength, as concrete takes the compressive strength. While PSC is a type of concrete that uses tendons to induce stress in the concrete, like a reserve energy from outside to face the external load. Here we will clearly explain the difference between reinforced concrete and prestressed concrete in detail. Difference between reinforced concrete, RCC, and prestressed concrete, PSC. 1. Cross-sectional area contributing to compression is high for prestressed concrete compared to RCC concrete. If you consider the cross-sectional view of an RCC beam with rebars at the bottom and clearly showing the neutral axis or the neutral fiber, NA. We know that when the beam bends under the load, say W per meter, the top portion is in compression above the neutral axis and bottom portion is in tension below the neutral axis. This is concluded based on the real effects of load on the beam, where the top fibers contract and the bottom fibers expands. As the bottom portion is subjected to more tension, and the concrete we know is weak in tension, we introduce steel reinforcement in this area. So to summarize, the top portion of the cross-section of the RCC beam only contributes to the compression strength, C. Below portion is only for tension, T. The purpose of concrete below neutral axis is mainly to hold the rebars upright as the layout. Now consider prestressed concrete beam with neutral axis NA. Here, before putting the beam to service load, we induce compressive stresses below the neutral axis area through tendons. This results in the bending of a beam in upward direction. This results in the bottom portion to be full of compression, C. Under service loads, W per meter, the beam bends, the top portion is subjected to compression C, while the bottom portion below neutral axis is already in compression C. Hence, the top and bottom portion of the cross-section contributes to compressive strength, unlike RCC beams. This is why cross-sectional area contributing to compression is high for prestressed concrete compared to RCC concrete. Hope you got the working. 2. RCC need large cross-sectional dimension than PSC to carry a certain amount of load. As explained before, to carry a specific load, only a portion of cross-section is involved in load bearing. But PSC puts the complete cross-section for load carrying. So to carry a specific load value, the RCC demands large cross-section compared to PSC. 3. RCC structures are prone to crack formation compared to PSC. We know that RCC structures are designed such a way that steel rebars fails first. When steel rebars yield first, the surrounding concrete that binds it together starts to separate. Yes, I am talking about the concrete portion below the neutral axis of the RCC beam that do not have any responsibility to contribute strength, but only to hold the bars together. So when the rebars separate, the concrete loose bond and cracks are formed at the bottom layers, also called as tension cracks. In the case of prestressed concrete, PSC, the situation is different. Before the external load is applied, the concrete member is already compressed internally by the action of prestressing tendons. These tendons apply a precompressive force to the concrete, which counteracts the tensile stresses that develop under service loads. Because of this precompression, the entire cross-section of the beam remains mostly in compression even after the external load is applied. As a result, tensile stresses are significantly reduced or completely eliminated, preventing the formation of tension cracks that are common in RCC structures. In short, RCC beams develop cracks because the steel reinforcement resists tension only after the concrete in that zone cracks. PSC beams, on the other hand, are designed to keep the concrete in compression throughout its service life, thereby minimizing or eliminating cracks. 4. Deflection in RCC is high while it is counterbalanced in PSC. In reinforced cement concrete, RCC, structures, deflection is generally higher because the concrete in the tension zone cracks early under loading. Let's say it is delta 1, positive deflection, as it is sagging. Once cracks form, the effective stiffness of the member decreases, allowing greater bending and downward deflection. The steel reinforcement alone resists the tensile stresses, while the cracked concrete contributes very little. In contrast, prestressed concrete, PSC, members are designed so that initial compressive stresses are introduced before the actual service load is applied, which result is upward deflection of delta dash, which is hogging, and therefore negative. Under the action of external load, there is the occurrence of deflection of delta 1 deflection, as in case 1 which is counteracted by the existing precompressive forces. That is, delta 1 is formed on the structure, already hogged, at delta dash deflection. So a total summation of deflection delta 1 minus delta dash is happening, which can be given as total deflection delta. Delta 1 is always greater than delta. That means the net deflection is significantly reduced, and in some cases, the member may even show upward camber initially due to pre-stressing. 5. RCC requires additional shear reinforcement compared to PSC. Before we compare, let's quickly recall what each type means. Reinforced cement concrete, or RCC, uses steel bars embedded in concrete to take care of tension and shear forces. On the other hand, prestressed concrete, or PSC, is designed with pre-applied compressive stresses so that the concrete can resist both tension and shear more effectively even before external loads act on it. Now, let's compare how they perform under shear. In RCC, shear forces are resisted by the concrete's shear strength and by tensile reinforcement like stirrups and bent-up bars. In PSC, shear is resisted mainly through precompression due to pre-stressing, along with the concrete's own strength and sometimes a few additional stirrups. In terms of reinforcement amount, RCC always needs more shear reinforcement to prevent cracking under load. But in PSC, this requirement is significantly reduced since precompression naturally resists most shear stresses. For types of reinforcement, RCC commonly uses stirrups, inclined bars, and bent-up bars, whereas PSC depends mainly on precompression, needing fewer stirrups. When comes to failure mode, RCC can crack under heavy shear if under-reinforced, leading to brittle failure. PSC, however, is less likely to crack because of its internal precompression, which improves ductility. Finally, member efficiency is higher in PSC. In RCC, the tension zone doesn't resist shear effectively, but in PSC, the whole section participates, making it lighter and more efficient. 6. RCC does not require high-grade steel or cement compared to PSC. In RCC structures, we generally use normal-grade materials like ordinary Portland cement, OPC 33 or 43 grade, and mild or medium-strength steel, such as Fe 415 or Fe 500. This is because the stresses developed in RCC are much lower compared to the ultimate strength of the materials. The concrete mainly handles compression, and the steel handles tension, but both work well even with standard grade materials. Since there's no pre-stressing involved, the steel is not required to be stretched or tensioned to very high limits, which makes the use of normal grades both economical and sufficient for safety. However, in PSC, the situation is entirely different. Here, the concrete is pre-compressed using high-strength steel tendons, which means both materials must withstand very high internal stresses before the actual external load even comes into play. As a result, high-grade cement, usually 53 grade or higher, is used to gain the required early strength, and high-tensile steel wires or strands, with strengths around 1500 to 1800 MPa, are essential to maintain the pre-stress. So, while RCC can be constructed using standard materials, PSC demands high-grade steel and cement to perform effectively and safely. Both RCC and PSC have their own unique roles and limitations, and that's what makes them application-specific. RCC fits perfectly for buildings and general-purpose structures where economy and simplicity matter, while PSC excels in long-span bridges, flyovers, and heavy-duty structures where strength and durability take the lead. In the end, it's not about which is better, it's about choosing the right system for the right structure. If you enjoy exploring such technical insights that connect theory with real-world construction, make sure to subscribe to Civil Engineering Fanatics, and don't forget to like, share, and follow for more civil engineering knowledge, simplified for learners and professionals alike. Because here, we don't just study structures, we understand them.